Hello, fourth grade, and welcome to topic 11. In this topic, we're going to focus on representing and interpreting data on line plots. Let's go ahead and get started with our short video lesson and then jump into our notes and guided practice together.
How can you read data in a line plot? The table shows the distance Eli walked his dog each day for 7 days. Line plots make data easier to read. A line plot shows data along a number line. Each dot above a point on the line represents one number in the data set. The numbers along the bottom of the line plot are the scale of the graph. What do the numbers along the bottom of the line plot represent?
Select your answer.
Interpret the data on the line plot. The most dots are above 1 on the line plot. The most common distance walked is 1 mile. The longest distance walked is 3 miles. The shortest distance walked is 1/2 of a mile. What is the difference between the longest distance and the shortest distance Eli walked his dog? 3 minus 1/2 equals 6/2 minus 1/2, which equals 5/2 or 2 1/2 miles.
Okay, so before we move on, we went through a lot of information here very quickly. Now I want to show you guys the line plot. We're talking about 7 days that he walked his dog. So you're going to find 7 dots here to represent each day. So 1, 2, 3, 4, 5, 6, 7. Now, 3 of the days he walked 1 mile. 2 of the days he walked 1.5 miles. One day he walked 1/2 mile. Another day he walked 3 miles. The nice thing about a line plot is you can see right away which one was most frequent, which one happened most often. The most common one that happened the most we see is 1 mile. The least common, or the ones that happen least often, are the day that he walked 1/2 mile and the day that he walked 3 miles. Now, there are other spots on this line plot, on this number line, that don't have any dots or any markings above them. That means he didn't walk those distances at all. But when we're using a number line, we need to break our number line apart into equal sections. In order for us to do that, that does mean that sometimes we're going to have points on the number line that we don't use. So here we're breaking it up into 1/2 size pieces. So none of the days he walked just 2 miles. None of the days he walked just 2.5 miles. Now, if we go back and take a look at the data table, let me see if I can scroll you guys back. If you look at the data table, he has 1.5 mile here, and he has 1.5 mile here. He has 1 mile here and here and here. So that's the 3 dots on the number line represent these 3 points or these 3 pieces of data in the data table. So 3 out of the 7 days, he walked 1 mile. 2 out of the 7 days, he walked 1.5 mile. 1 day he walked 1/2. 1 day he walked 3. And that's the data that you're seeing represented here in our line plot. So sometimes we'll use dots, sometimes we'll use X's. Whichever one you're using, it represents how many times that number showed up in your data. So 3 times we saw the number 1, so there's 3 dots above the number 1. But only 1 time we saw the number 3, so there's only 1 dot above the number 3. Now let's go ahead and take a look at your notes and your guided practice, and all of this will make a little more sense in just a moment. So how can you read data in a line plot? Well, a line plot shows the data along a number line. Each mark above a point on the number line shows one number in the data set. So one of the times it happens is each one of those markings. So if you see a point on the number line that has 3 markings above them, or 3 dots or 3 X's like we just saw, that means we found that number appeared in our data set 3 times. If you see 5 dots above a particular number, that means that number happened 5 times, or it showed up 5 times in our data set, and so on. Now for our first example, it says Emily went fishing. She plotted the lengths of 12 fish caught on the line plot below. What was the length of the longest fish caught? What was the length of the shortest fish caught? So first, before we do anything, let's take apart this number line. So we have our title at the top, the length of fish caught. So that tells us what our line plot is going to be about. Just like any form of graphing that we do or showing our data, we need to put something in there that tells us what we're looking at. So the title goes on top, the length of the fish caught. Her number line is broken up into fourths. And she goes from 6 until 8 2/4. So our number line is equally spaced, just like always when we make a number line. We put the units that we're using right underneath the numbers. So here we're measuring in inches. Now the dots over here are how many of each kind of measurement we got. So how many times, how many fish were 6 3/4 inches? How many fish were 7 2/4 inches? So the number of circles tells you how many of each kind there are. Now the total number of marks, whether it's circles or X's, tells you the total number of fish. So here in the question, it tells us she plotted the length of 12 fish. You'll see that there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 12 markings to represent the 12 fish. Now, the number of marks above a number tells you how many are in that group. So how many fish were 7 3/4 inches long? 2 of them were. How many fish were 7 inches long? 1 was. So the mark, for example, we have 3 fish out of our data over here that measured 8 1/4 inches long, because there's 1, 2, 3 markings. That tells us 3 of the fish had that measurement. Now the longest fish is going to be the biggest number that has a marking above it. So 8 2/4 is our biggest measurement. So the longest fish that we had was 8 2/4 inches. We're not going to see 8 3/4 inches because none of them measured that much. There's no marking above it. So it has to be one that has a mark above it. Now the shortest fish caught is the smallest number that has a marking above it. So not 6, but 6 1/4 is going to be our shortest fish. And remember, if there's no mark above that number, then there are 0 of that particular kind. So there were no fish, for example, that we caught that were 6 inches long. So we don't use that as the smallest number because none of the fish that we caught were that length. Now let's take a look at another example. It says, Mr. Dixon recorded the time it took for students to complete a project. Which time was most often needed? Which was least often needed, and how many kids were in the class? So we have 3 parts to this question. So the one that was most often needed is going to be the one that has the most X's above it. That means that was the one that got picked the most often. The one that was least often needed is the one with the fewest number of X's above it. So here we use X's. In the previous example, we use dots. You can use either one. Now we can see that the most often needed one was 2 2/4 hours. And we can see this right away because we have our data set up in a line plot, and that's a lot more visual. It's kind of like a graph where you can see right away. It's very easy to figure out and look at your data and see immediately which is the biggest and which is the smallest. So most often needed was 2 2/4. Least often needed was 3. So 2 2/4 hours was the most one that was picked, and 3 hours was the least one that was picked. So it has the fewest marks above it. Now the total number of kids is just you counting the total number of X's there are. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we can see there's a total of 13 kids in the class. Whenever you want to figure out the total, you count all of the X's because each one of them represents one student's time or one piece of data. If you're looking for the total number of data points that you have, you count all of them. Next, let's get into your guided practice. So for number 1, it says, how can you tell the longest distance Eli walked from the line plot? So to find the longest distance, again, you look for the biggest number that has a mark above it. If there's no mark, it doesn't count. Number 2, if a line plot represents 10 pieces of data, How many dots or X's would it have? Explain. Well, if it represents 10 pieces of data, then it would have 10 dots or X's above it because each one of those represents one piece of data. For numbers 3 to 5, we're going to use this line plot over here on the right. We can see that it's measuring giraffes' heights, and the unit we're measuring in is feet, and the scale we're using is half inches, and we're starting from 14 through 16.5. So for number 3, how many giraffes are 14 feet tall? So we're going to look at the 14 and count the number of X's above it. Here we can see that there are 2 giraffes that are 14 feet tall. For number 4, it says, what is the most common height? The most common means which one are you seeing the most of? Which one has the most X's above it? So the most common height, or most of these giraffes, are 14.5 feet tall. And how tall is the tallest giraffe? Again, you're going to go across your number line until you get to your biggest number that has a marking above it. So we're not going to use 16.5 because there's no marks above it. That means none of them were that tall. The tallest and the biggest number that has X's above it is going to be 16. So the tallest giraffes that were measured here were 16 feet tall. Now remember, when you use a line plot, the number of data pieces that you have are the X's or the dots. You have to have a title. You have to list what units you're using. The scale that you're using is going to be based on the data that you have. So if you have data points that have things that are measured with eighths, then you're going to break up your number line into eighths. If you have things that are measured in fourths, you'll break up your number line into fourths, and so on. So you want to make sure that you're picking the correct scale to show your data, that you're labeling all the parts. So you're labeling the units and you're labeling the title, and you're making sure that your work is neat and organized. You can see over here, since I did it on graph paper, I'm putting one X on each one of these lines. You can do the same thing with notebook paper. Don't squish a bunch of them together and then make some of them really far apart, because then it makes you, it can make you accidentally read your data the wrong way. All right, that's it for this lesson. If you have any questions, let me know. Otherwise, have an amazing day. Take care. Bye-bye.